Hello mga Kakasyo Nation, I'm Engineer JD. This video will be different because today, I will discuss some tips for you to be able to do faster calculations in our Casio FX 991MS 2nd edition. Let's get started. So there are several tips that I want to share, but here's some of them, and it takes practice for you to be able to master them. First tip is if certain characters are optional in the calculation, omit them. So the first tips are more of some tricks to reduce the number of inputs in your calculation. So first, if you have certain characters, not all of them are optional to be inputted in the screen, then you don't need to include them in the calculations. For example, let us take the simple example of calculating the sine of 42 degrees. Now, let's assume that our calculator is in comp mode. So in comp mode, to be able to access comp mode, by default, when you turn on the calculator for the first time, it's in comp mode. But if it's not, you can access it using mode and then 1 for the comp mode. And by default, all angles are measured in degrees in this calculator. But in case it's not, you can enter shift mode and then let's go to deg 1. Okay, so that's how you access degrees. Now, let's calculate sine of 42 degrees. So the standard input will be this sine. Some people would like to put parentheses in their calculations because, well, it's safer to enclose everything in parentheses to be able to avoid confusion later on. So let's input parentheses 42, and then at the same time, because the angles are in degrees, it is not required to input the degree symbol in this calculation. So let's now enter the close parentheses and then let's press equals. So in this case, it is this value. Now, in this case, we can still reduce this because the parentheses are not required in this calculation, because the sine function or any trigonometric function here automatically requires an integer or a real number for this to work. Now, if it encounters an operation without a corresponding parenthesis, then it will break the input. Okay? In this case, since the input is only an integer, then the parentheses are not required because the sine function automatically detects it. So we can just input sine 42 without the parentheses, and it will give us the same results as before. Now, as another example, let's have a longer one, which is sine of the quantity of 30 degrees plus 45 degrees. In this case, because the argument of the sine function is composed of two numbers separated by a plus sign, then clearly parentheses are required. So you can input like this. You cannot remove the parentheses, and I will explain later on. So let's input sine of open parenthesis 30 plus 45 close parenthesis and then equals. So that's the value. Then that's how you calculate it conventionally. However, the concept of parenthesis in Casio is that in many cases you do not need the closing parenthesis, because in the calculator, once you have the open parenthesis, then the calculator will immediately recognize that everything after that open parenthesis will be a single group. Okay? So which means we can remove the closing parenthesis. So automatically, because we have an open parenthesis, this 30 plus 45 is recognized as one group within a one pair of parentheses, without explicitly writing the close parenthesis. So in this case, we can just remove the close parenthesis and we'll still have the same answer as before. That's one trick. However, you do not need, or it is not allowed to remove both of them, because again, without the parenthesis here, the sine function will only recognize integers. So in this case, it will be read as sine 30 degrees plus 45, so which is a different expression because the sine function only recognizes 30, and upon encountering the plus sign, stops reading the input. So in this case, it only recognizes sine of 30 degrees. So that's a different expression. So again, the first tip is if you can remove parentheses, then remove them, but you need to know when to remove them. So in these cases. Next, for another example of this tip, let's have this equation x squared plus 3x plus 2 equals 0, and we are to solve one of the roots of this equation using the shift solve utility. So to be able to do that, let's input this command to access the variable x. Let's press alpha, the alpha key, and then the close parenthesis. Take note of the red variable above that close parenthesis, that's x. So you can access that using the alpha key, x. And then squared plus 3x, so alpha and then x, and then plus 2, and then the equal sign, so that's alpha and then calc, alpha and then calc, accesses the equal sign, and then 0. Okay, so now we've inputted an equation. Let us now do the shift solve thing. So let's press shift and then calc to enter the shift solve. Now we are being asked for the value of x. So in this case, let's assume it's 5 for the guess value. So let's press 5 and then press equal sign first and then shift calc. So now we are now given the value of one of the roots of the equation, which is x is negative 1. Now in this input, notice that the equation ends at 0, so it equals 0. It's in general form. However, the calculator automatically recognizes it. No? In the absence of that equals 0 in your expression, automatically it's equal to 0 when you do shift solve. So that means you can actually remove the input alpha calc and then 0, or the equal 0 part, and just input the first expression. So let's do that. So here, let's remove the equal 0. So let's remove that. So we just have this input, and then doing the shift solve, you will see that the result is still the same, because in the absence of equal 0, the calculator automatically places equal 0 there and then proceeds with the shift solve calculation. So the results are the same. Now that's another tip. Now, related to that, removing of arguments or removing of certain parts. Now, related to that is, let us mentally rewrite certain expressions or equations so that there are two things. First, we only need to input expressions instead of simple equations. For example, let's have this equation, so which is based on the law of sines, which is typical for finding the sides and angles of an oblique triangle, so using the law of sines. Now in this case, the variable x is on the numerator, and clearly it is a linear equation in one variable. Now instinctively, because there's a variable x, many people will do input that equation and then do the shift solve utility, which is okay, it serves the purpose, okay? But another way is, don't use shift solve, because you can manipulate this equation and get this value of x, and instead of inputting the expression or the equation and doing the shift solve, you can just input that expression in red and give the correct answer as before. So that's one way. Now, instead of solving equations or mentally algebraically manipulate this equation to be able to get an expression for that variable and then just input it, that's the same. Another one is, we convert complex equations into simple ones, and one of the benefits of this is that complex equations are taking longer times to solve, but when you rewrite it into simple equations, it will boost your calculation time. It will make it shorter. For example, we have this equation 1 over square root of x equals 2 all over square root of x minus 1. So the culprits here are the variables in the denominator coupled with square roots in the denominator. Programmatically, these two things make calculations longer. No? In order to avoid it, we convert it to square roots in the numerator or variables in the numerator. So what we can do is to cross multiply this equation, and you will get this. The square root of x minus 1 is equal to 2 square root of x. Now, not only this is simpler, but the square roots are in the numerator and the variables are in the numerator. So if you try to solve it in the calculator, you will see that the equation in red takes shorter time than the equation in the previous one. So which is a great benefit for the solvers. Now, another tip is to use memory variables effectively. So notice in your calculator, there are 9 variables here. So A, B, C, D, E, F, and then X, Y, M. So these are 9 variables. That's a lot. And you can use these variables anywhere you want to be able to store values, access them, or to use them in equations to solve for their value. Now, exemptions to this, although these are 9 variables, in modes other than comp, like vector mode or matrix or complex, you can only use up to 3 variables, and that's A, B, and C. They are the only ones. Okay. Now, how do you use these variables effectively? Let's have this example equation. Now, this is a very long equation, so which is typical in civil engineering in the calculation of analysis calculation of doubly reinforced beams. So this is the equation that is very long. And if you try to input this verbatim, you will find out that in many cases, you will exceed the 80 limit character set by this calculator. So that's not a good thing. So what we can do? So in this case, let us use variables. So we highlighted certain values. Instead of typing them explicitly, these values, we can use variables like this. And so this variable A has the value in red, the variable B has the value in blue, and then the variable C has the value in orange. So all we need to do is to input this last equation, and then when we do shift solve, then the calculator will ask for each of them, the values. So you can do that, input all of them, and then later on solve for the value of X. So which is not only saves time, but also saves yung input natin. And that's how you do memory variables effectively. Next tip, number 2, is if there are certain arguments which are optional in the calculation, we need to try to include them, because removing them does not necessarily mean that the accuracy or the speed is optimal. So examples of that are derivatives and integrals. So for example, let us calculate this integral, which is obtained from this figure in calculating the area of this segment. So it's this one. Now, if we try to input this integral using this key sequence, so let's input that. So let's go back to comp mode first. So comp 1. Let's input this integral. So integral. So by the way, in the calculator, integrals are inputted using the sequence. First, we input the integrand. So in this case, 2, and then square root of 6 squared minus x squared. So that is 1. And then, comma, we input the lower bound, which is negative 6. And then, comma, we input the upper bound, which is negative 6 plus 3 in this case. And then close parenthesis. Now, pressing equals. So you will see that in many cases, or in some cases, calculation of integrals takes a long time because the calculator uses Simpson's rule, method of approximation, in order to calculate integral. So let's wait for a bit and we will discuss how we can improve the speed of this calculation. So it's taking a long time, and there's the answer. So it got the answer of 22.11, and it took us 36 seconds to calculate this integral. So in time-pressured problems, like in exams or in contests, that's not a good thing if this time is too long, no? So instead, we can now adjust the accuracy of this result, but at the same time, increase the speed of calculation. So in this case, the calculator has used 9 as the fourth parameter, as the hidden fourth parameter in the integral. So what is this hidden parameter? So this hidden parameter dictates the accuracy of your result, and in the context of Simpson's rule, it dictates the number of divisions of your integral. which is equal to 2 raised to 9 divisions. So if you do the same thing, edit this input. So let's have the fourth parameter, comma, and then 9, you will get the same thing, which is 22.11. What if, however, let's change that to 7? What will be the changes? What will be the result? So let's change that to 7, and then let's press equals. So it's still longer in this case, but it's incredibly faster than the one with 9. So it got the same answer, but in 9 seconds. So that's 4 times faster than before. So that's a good thing. Now we can make that even faster by using a smaller value for the fourth parameter. So let's use 6 instead. 6, and then press equals. And then it's even faster. But notice that the result has become less accurate than the previous one. So it's just now 22.1. But the calculation is faster. It's 5 seconds. And if we use even smaller value of the fourth parameter, so let's use 4. Let's press equals. Now it's a flash. So you got the same answer, 22.1, in just 1.5 seconds. So try to decide on the balance between the accuracy and the speed of calculations. In many purposes, for integrals, 5 is enough. So yung fourth parameter, 5 is enough for that. Now for the third tip is to memorize the most common and useful unit conversions and constants. So there are many of them, and it's very common use that you don't need to search the calculator for that. Now, although the calculator has the conversion and constants utility to that, but try to use them if you really forget that conversion or that constant. But otherwise, if you memorize them, just input them directly. For example, the common use conversions are 1 inch is 25.4 mm. Try to memorize them. And then 1 feet is 304.8 mm. So try to memorize it. And then in my case, converting from PSI to megapascals requires us to multiply 6.9 to the KSI. So KSI is 6.9 megapascals, so for concrete. And then for the constants, of course, the value of G, which is 9.81. In the calculator, it's more exact. It's 9.80665. But in many engineering purposes, 9.81 is enough. It's 9.81. And for feet per second squared, it's 32.2. And it's not even in the calculator. So try to memorize them. And it speeds up calculation because you do not need to search for those conversions or constant. Lastly, our last tip is, I think, the most important, to memorize and internalize lots of calculator techniques and use them in a variety of examples. Again, highlighted "and" because you cannot internalize and memorize them until you apply it in several examples. For example, in the calculation of the moment of inertia, so using the parallel axis theorem, so that's the summation of centroidal moments of inertia of each shape of the given component, then plus AD squared. So that's how we calculate it manually. But the calculator technique part, so its use here, is given by this formula. It's the summation of the moments of inertia plus n sigma squared. N is the frequency and sigma is the standard deviation of the population, with both of which are accessible in the calculator. To be able to memorize it and internalize it, you need to know where this formula came from, where this calculator technique came from, and then use it in a variety of examples, actually solving them using this formula and calculator technique. That's it. So that's the 4 tips that I have to boost up your calculations in the Casio FX 991MS 2nd edition. That's it for today, mga Casio Nation, and see you on the next video.